by Shelby,
Alex,
and Lauren.
Plate tectonics.
What is the theory of plate tectonics?
Plate tectonics is the theory that all the continents are slowly drifting around the Earth. The theory of plate tectonics was introduced by Alfred Wegener in 1915. When he realized that the coastlines of Africa and South America looked like they fit together, he hypothesized that all the continents had once been one large landmass. He called this supercontinent Pangaea. Pangaea started to break apart about 200 million years ago, eventually becoming the 7 continents we have today.
But why did this happen?
The Earth contains several different layers. The crust, the mantle, which contains the lithosphere, asthenosphere, and lower mantle, then comes the outer and inner core. The uppermost part of the mantle, or the lithosphere, is broken into many sections called plates. These plates are in a slow but constant motion. There are also different boundaries between these plates.
What are boundaries?
Boundaries are places where something occurs between two plates. The types of boundaries are convergent, divergent, and transform. Convergent boundaries. This is where two plates push toward each other. This can cause earthquakes, volcanoes, and also form mountain ranges.
Divergent boundaries. This is where two plates move away from each other. This can create things like rift valleys, ocean basins, and volcanic islands.
Transform boundaries. At a transform boundary, two plates slide past each other. This causes spreading of the seafloor ridges.
Seafloor spreading.
What is seafloor spreading and how does it happen?
Mid-ocean ridges are the places where plate tectonics, slabs of rock in the lithosphere, are moving away from each other. Scientists found these ridges using sonar. Sonar is a form of sound that reflects off of objects underwater. Depending on how long it takes the sound to return, you can determine how far away an object is. How loud the sound is when it returns can help you tell how large the object is. Interesting fact: lots of animals, such as dolphins and bats, that live in places where it is dark a lot of the time, use sonar to find food and navigate. Seafloor spreading is when the plate tectonics move apart along an ocean ridge. The plates move the seafloor with it. A crack forms. Out of the crack seeps magma. When this very hot liquid meets the cool ocean water, it cools and forms new crust. As the magma builds up layer upon layer, small hills of rock form. Gradually, over a long period of time, the cooled magma forms mountains.
Who discovered this?
An American geologist named Harry Hess discovered this amazing process. He had been in the army. While there, he discovered landforms that he called guyots. Guyots are flat-top mountains at the bottom of the ocean. After he left the army, Mr. Hess was very curious about the guyots. In 1953, Maurice Ewing and Bruce Heaton discovered the Great Global Rift. The Great Global Rift is a canyon with mountains in it. This discovery led Harry to his seafloor spreading theory. Mr. Hess's theory actually proved Alfred Wegener's theory about the continental drift to be correct. Mr. Hess's theory provided the missing link: why the continents are spreading apart. The continents are spreading apart because as the ocean floor spreads out, it takes the continents with it.
What is the evidence for Mr. Hess's theory?
Alvin the submarine and his crew discovered rocks that looked like a big jumble of oozy stuff, yet they were hard. These rocks were made of molten material, magma, and showed how the molten material cooled quickly. This discovery was one form of evidence for Hess's idea.
Magnetic strips proved Mr. Hess's theory in that they showed when the Earth's magnetic field had reversed. The rocks were found in the order of most recent being closest to the ridge. This shows that the new seafloor formed over a period of time.
The final supporting evidence was found by the Glomar Challenger in 1968. The Challenger collected rock samples from inside the Earth. The rocks were dated and found to be older the farther away from the ridge they were. The closest rock was the youngest, and from there the rocks were just older and older.
Around mid-ocean ridges, underwater vents form. At these vents, water seeps into the ridge where seafloor spreading occurs. When the water gets heated by the high temperature of the magma, it shoots up. At these vents, there is life. Although there is no sunlight at these ocean depths, life is supported by the compounds and minerals in the heated water. Other life is supported by the life that feeds on the vents. Life at these vents includes
tube worms,
Jericho worms,
and orange worms.
duck,
Sean. Subduction. Get it?
subduction. What happens next?
Subduction is the process by which the ocean floor sinks beneath the deep ocean trench and then back into the mantle. Subduction happens after seafloor spreading. The new material that emerges when the seafloor spreads is called magma, or molten rock. This is cooling magma. When magma cools, it becomes cooler and denser. Then gravity begins to take its effect by pulling the magma towards a deep ocean trench. This happens after the seafloor spread and pushes the old seafloor into a deep ocean trench. Then it slowly sinks back into the mantle. This only happens in a subduction zone. Subduction zone. A subduction zone is where subduction occurs, like a deep ocean trench. A deep ocean trench is where the older seafloor sinks back into the mantle. A deep ocean trench is like an underwater canyon.
Is this an underwater canyon?
Yes, Shelby, it is an underwater canyon. Or something like the Grand Canyon, underwater.
This is the Grand Canyon.
The whole subduction process takes tens of millions of years.
Wow, that's a long time!
The Pacific Ocean is shrinking because the old seafloor is sinking faster than the new seafloor is appearing. The Atlantic Ocean is doing just the opposite. The new crust is forming faster than the old crust is sinking, expanding the ocean.
Thank you for watching this presentation. We hope you enjoyed it.